Hey guys, welcome back to our BrickBreaker project. Where we left off is, so far we just got a paddle that moves, borrows all the Box2d stuff, makes our own little SFML shape for it, and then we have our ball that bounces. A couple things I want to add today. Maybe we'll add a brick class. The other problem is I want to get the ball to bounce off the paddle in different directions, and you'll see one more issue is I can hit the paddle with the ball and slow it down or speed it up because, see that? It is physics, it is energy. I can add more energy into the system with my keyboard. And I don't want to do that because it makes the game un-BrickBreaker-like. Okay, so I am going to slow this ball down if it ever gets sped up. I'll probably do that in this function here called update position. Remember that this sets the position and rotation of the ball based on all the info it grabs from the Box2d world and then draws it. So that's a good spot to just make sure it's not going too fast. And if it is, to slow it down. Now, the way to do that, a good way to do that is, first of all, I already know the speed I want it to go to, right? Because I choose the speed in here when I make the ball. And if I want to speed that up later, I can maybe do that in a function as well. But, I think the ball starts at a speed of, let's see, 10? Is that right? Let me just hover over that again, see what happens. Would have been nice if it auto-typed, but it doesn't. Sorry. It's XY speed, XY radius, speed, and angle. So this is the speed, 300 pixels per second, or whatever that works out to be. Okay, so I'm going to go to my ball class, and before I, just somewhere in here, maybe before the draw, I will slow its speed down to 300 no matter what. Now that's an issue because I need to know what direction it's going in first. And there's some hassle to doing that. What I'm going to do though is just go to physics.h, and there is a limit velocity function here, which takes in a block and takes in the speed. Okay, so I'm just going to steal that code, hit copy, go to my ball class, and that should be good. This shouldn't say B, but instead should say body, and this should say body as well because again we are working with our own Physics2d body, and I can keep the speed actually here as well. So what it does is it gets the linear velocity and then sets it to 300. It finds out like basically the angle that it's going at, and keeps the angle but still sets it to 300 or whatever my speed is set to. So hopefully now if I run this I won't be able to see that. It's unphysical, yes, okay, I do agree with that. I put a lot of energy into that ball with the paddle and I get nothing out of it. But that's okay. Maybe BrickBreaker isn't the best use of physics engine, but because it's a very unphysical thing. There's no friction. There's no stickiness to anything. There's no energy, but in the system, well, the energy is just kind of constant. But that's why we're working around it to get rid of some of the things that we don't need about the physics engine, and this is one of them. So I'm going to leave a little comment here that says limits speed of ball don't let energy add to world. Okay, so that's good. Another thing I might want to do is I might want to have a check collision function. Right, I might want to know when my ball is hitting my paddle. So let's do that. This one will be bool. I will say check collision. Okay. And I need to pass it something that I want to see if it hits with. And for me, I need to check to see if the ball is going to hit the paddle. I could also, in my paddle class, check if the paddle hits the ball. The problem with that is, so I could make a check collision here and pass it the ball. But I don't really need to do anything to the paddle when they hit. I really only need to do things to the ball if I know it hits the paddle. Right now it's just bouncing like, whatever angle it comes in at, it bounces off at that angle. But I want to bounce it off at different angles on that paddle. So I'm going to add the check collision function in here. And I am going to need to pass it in a paddle like that. So I'll just call it P1. That. Now, this is probably going to, let me just write return true here. And I don't know if my ball even knows what a paddle is right now. Let's see if it gives me an error. It says paddle has not been declared. And that's because this file only knows about things that have been included up here. Okay, so I'm going to say hashtag include like that, and then I write the word paddle.h, and hopefully this, or paddle.cpp rather, this doesn't complain at me. Redefinition of structure paddle. Okay, so this is a problem we haven't encountered yet, but what's basically happening is I'm including ball, right? And I'm including paddle here. And so ball is including paddle as well. So basically paddle's getting included twice. And the problem happens that when it gets included twice, basically what it's doing is just writing all the code out in front of the main at compile time. So what it's seeing is basically struct paddle, right? I'm making the struct paddle, and then it sees again I'm making struct paddle again, and it's like, what the heck? You can't make this thing twice, right? Same thing with a variable. You can't make a variable this twice like this. Float num and float num. The computer's going to have a big issue with that, right? So the way to protect yourself from double calling these structures, especially when some of them are including others inside of themselves, is there's a couple ways you can do it. Here's the easiest way. You write the word hashtag pragma, and then you write the word once after it. That's a Windows thing, by the way. I don't think that works in Linux or Mac. But we'll use it here for now because it's easy. And I'll do it here too. Pragma once under basically any files that I make, I should put it in. I don't obviously need to put it in main, but let's see if that fixes our issue. Well, give me a little warning about it, but it's okay. Oh, it doesn't like it because it's in the main file. Because I'm just including the CPPs here. So why don't I get rid of that then? That's good to know. And I'll do this. I'll say hashtag if defined like that. If n defined. If not defined. Okay, and I'll just make up a name like this is ball, right? So I'm just gonna write ball underscore CPP like that. So it's saying, and then it actually types an end if that I need to put at the end of my file. So you will see this in a lot of C++ files. It's called a header guard, meaning it's there to protect your file from getting called twice. So if it doesn't see this ball CPP keyword, it will execute all this code, put all this code in front of your main. Okay, but not only that, it'll also define. If I put a define like that, it'll define ball CPP. So the next time I go to call it in paddle, if I went to go call my paddle, or my ball and paddle, this would be defined and it wouldn't redo all of this code. Okay. So I'm going to put a header guard on my paddle class as well. So if not defined, and then I usually just give it the uppercase name of the file. And some sort of, it puts the end if there, which I need to put around all of my code so it doesn't get called twice. Keeping in mind that I do need to define the word paddle, CPP like that. And hopefully that will, hey boy. I think it's defined, sorry, not def. It's been a while since I did this. Let's see if that fixes it. There you go. All right, cool. Okay, so now I can call a paddle inside a ball and a ball inside a paddle, and the snake won't eat its own tail, so to speak. And there it is, my bouncing ball. Cool. So let's do a collision. Maybe we'll just do a collision today, and then this weekend I'll make another video of how to get the ball to bounce off the paddle at the angle that it kind of, depending on where it hits in the paddle, it'll kind of bounce off in different directions, so you can steer your ball a little bit, make your game actually interesting. All right, so here is my check collision function. I haven't done anything with it. I am going to simply, for now, just, I don't know, maybe see out it in my main. What I'll do is I'll go to physics.h and I'll find the check collision function in there. There's two. Checks the collision of a block and any other block. That's not the one I want. I want the function that checks the collision between two blocks, right? So I'm going to copy this code that's inside of here. Hit copy. Go to my ball class and hit paste. Now, I have B1 and B2 in this code. B1 is the first body, so I will just write the word body there. And B2 is the paddle's body. So I'm going to write P1. If I write P1, it'll break. And boy, does it ever. Okay, it doesn't know, like, this was supposed to be a Box2d body, and I passed it like my paddle that I made. The paddle does have a body, though, so if I just write in here P1 dot body, then it will be fine. Hopefully. Yes, it's fine. So let's see out it to see if it actually is checking if this thing is hitting the paddle. So just anywhere here, I'll write see out, and then I'll write my ball is called main ball. I'll see my function here, check collision. I will pass it the name of my paddle, P main paddle. I do want to fix something in here in a second as well, but for now I will run this and see that it works. 0, 0, 0, 0, 0, not hitting. That makes sense. Will it say 1 when it hits? Yeah, it did. It's hard to tell. Let's see if I can pause it. It just hits it once, right? So there's my little 1 there, if you see right there. So that's good. It knows it's hitting it. We'll do some more paddle collision coming up in the next day or so. I just want to leave you with that for now. One other thing I want to do here is I want to get out of the habit of passing big objects into functions. When you do this, check collision, every time check collision gets called, it has to make a copy of this paddle, and that requires however many bytes a paddle is. Now, a paddle is going to be a fairly big object, right? It has lots of stuff in it. So instead of doing that, what I'll do is I'll put an ampersand sign in front of here like this. You've seen this before. What it says is don't actually pass it the paddle, pass it the paddle's memory address. And the memory address is only 4 bytes big. So instead of every time I call check collision in my main, do I want to recreate, let me just get the size of my paddle. It's probably not that big right now, but it's going to get bigger as we add more stuff to it. So if I write size of main paddle here, and I'll get rid of this C out because I want to be able to see it without it scrolling off. And so it's 288 bytes, okay? As opposed to the memory address of main paddle. Well, let me do that. Let's see. I doubt it. No, it did let me do that. As opposed to the memory address of my main paddle, which is only 4 bytes. So it's way smaller in memory. So if I'm going to call check collision 60 times a second, do I want it to make a copy of a 288 byte object 60 times a second? Or do I want it to make a copy of a 4 byte variable every 60 times a second? I'm going to choose the 4 bytes. So that's why I write an ampersand sign in here, and it's fine. I don't have to change any of my code. It just makes it so that it's more efficient. The other thing I want to do is, I mean, you don't have to do this for this example because you know, you're working on your own and you're not depending on someone to come along and do something to your code. But this code, check collision of my paddle, should never be able to change my paddle. But because when I pass it a memory address, it will allow you to change it. So I could go in and like say p1 dot like set something, right? And it would allow that function to actually change the paddle. So a lot of times you will see in code that people put const in front of that. Okay, so you will see that a ton in SFML. Let's say I go to the SFML website right here. And I'm just going to go to the API documentation. If I just grab some class and look at some of the functions in there, like let's look at rectangle shape. So if I look in here, look, I got a const and a vect and an ampersand for that function. Here, const color and const int rect and const color and for things that only take floats, they don't do it because a float is 4 bytes anyway, so it doesn't matter if you use the float itself or the memory address. There's still 4 bytes. There's no savings there or efficiencies. But vector2f is something that's going to be bigger than 4 bytes, so they write an ampersand and they write a const, and so on and so forth. So you get the idea. That's what we've been trying to do with us. We're going to write const paddle ampersands, just so that you know and that you're more aware when you see it in other people's libraries and stuff. That's why it's there. Okay, so stay tuned. I am going to be posting more code shortly so we can get our BrickBreaker project done. What we'll try to do is I want you to try to make a BrickBreaker project. It doesn't have to be super involved. I know it's hard if I'm not there to work out all the bugs and stuff, but I think it's kind of a cool project for you to work on. There's no pressure to do well on it or to make it, you know, a super duper shining star example. But if you can work on it, that'll be good. It'll help you with your coding. And then I want you to start a final project, maybe like a month-long project just for the month of June, where you just kind of make something that interests you in C++. And again, that doesn't have to be like some 10,000 line code project or anything, because you're at home. I'm not there to help and supervise and things like that. But that's the goal for this class, just to get these last 2 projects done and have something to show for what you've learned over the last couple of years in computers. Okay, so I will post how to get that ball to bounce off that paddle. I want you to try to make a brick class, and it shouldn't be too tricky to do that. And if you are having trouble with that, let me know. But you will have to make a vector of your bricks. And you can see now that how to do a collision function as well. Okay, I'm starting to ramble here, so I'll get going, and we'll hear from you soon. Bye.